This is so cool. We're in a Euro truck.
Let's get
Hell
trucking.
yeah, brother. Can you 2-foot launch it? Does that help? To hold it on the brakes under the power?
Don't need that.
Oh,
You have instant- I mean, you have instant torque, right?
Yeah.
You only need that if.
hell yeah. Dude, that's fast. Oh my God. It's one of those things where, of course, around Nikola, there's a lot of skepticism. Hydrogen brings a lot of questions. I think it was great to learn more about what you're doing, experience the truck firsthand. I want to do one of the Flagstaff routes with you guys, put 80,000 pounds on this thing or whatever you can, and then go up to Flagstaff. This video is brought to you by Nokian Tires, a leader in safety and sustainability. Maximize performance and efficiency with their made in USA all-season tires and their dedicated Hakkapeliitta EV winter line from the inventor of the winter tire. Learn more at nokiantire.com/EV. This video is also brought to you by Magna, forward for all. Hello and welcome to another Out of Spec Reviews video. You join me back in front of a Nikola hydrogen truck. This time, actually, we did the battery electric truck already. I'm joined by Christian. You're one of the engineers of this project.
That's right.
So I know there's a lot of questions whenever we bring up, of course, Nikola, whenever we bring up hydrogen and vehicles. So there's a lot to dig into, a lot of your experience with the truck, what you guys are working on. We're going to go for a drive. And so I'm really looking forward to this. We actually had a great time riding with some of your colleagues in the battery truck.
That's right.
And so want to ask you a lot of questions on that, how this is different. I don't know, so much to learn about hydrogen trucks. We'll get into the conversation first about hydrogen as a fuel source versus battery electric. Then we'll go on a full tour of this, and then we're going to drive it. So we got a lot to do. Join us on this video. Christian, this thing is freaking huge. You got a Class 8 cab over.
Yes,
Is it the first homologated cab over in the US since like the 70s or 80s?
Well, I think there's been some cab overs that stuck along.
Yeah, like
A little
Freightliner had the
longer,
one that,
longer.
Yeah.
You also have actually some other companies ever since we brought the cab over back to the market have been kind of following suit and are bringing some of the cab overs back into the US as well. Hyundai, for example, is running some demos with a cab over. So I think it's about time to bring the cab over back to the US.
Hell yeah, I've always been a cab over fan. I love it. I mean, the real main concern was safety originally. That's why we went to like the American truck style.
Right. I think
But
it
in
was
Europe,
yeah.
these things are all everywhere.
That's right. That's right. So I think it was safety, but it was also kind of the noise, the rattling, the vibration, because you had all of these, old big diesel.
Yeah, because you're sitting on top of
and you're
it.
sitting on top of it, and so it wasn't necessarily a nice experience in these old trucks. That's obviously completely different today. Even with modern diesel trucks in Europe, you don't have that same issue, and then specifically for a zero emission truck, I mean, that is obviously gone, right?
Yeah.
In Europe, yes, they're running only cab overs, and the reason is you have such a limitation from a regulatory point of view in the overall length that you really can't afford those long-nosed, big American rigs.
Sure.
You have to keep it tight. So this is actually what we're using here. The dimensions of that cab is what in Europe is a sleeper cab. So that's all it is the little bunk behind the seats.
Well, let's take a look down the side. So the body in white is sent from Iveco, is it?
Yeah, that's right. That's right. We're still working together with Iveco. We used to have a JV for the European market with them. That got recently essentially dissolved, or Iveco took it over to then focus on the European market. We wanted to really focus on the North American market. The US and also Canada is very important. And so we decided to essentially change our partnership, but we're still working together as it relates to supply of a lot of the components. And the cab, the body in white, is one part that we're actually getting supplied from our partners.
And the hydrogen truck and the battery truck, if you guys come around to the backside, just so we can show you, are the same bare chassis.
It's a very similar chassis.
What's different? What's different?
So, I mean, you can see that there's a lot of different components that we're using on the hydrogen truck versus the battery electric truck. And so a lot of the attachment points, right, the brackets and so on are different. So if you talk about the frame rails, you know, the hole patterns and so on, especially once you go into the forward area here, are different. So it's not the same frame we're using. The cross members are a little different too, based on the structural analysis and durability design. But they're very similar.
And the cab is the same.
The cab is the same.
Okay.
When you look into the rear areas, though, that's where we obviously have a lot of shared components. We have the same drivetrain basically we're using, the E-axle and also the tag axle assembly, the suspension. So all of that is
everything back here, battery electric or hydrogen, you get the same feeling as a driver. There's no, you get regen.
Very similar feeling, yeah.
Okay.
There's a few differences in regenerative braking capability because of the battery size, obviously.
What is the battery size on this?
The battery size, we have 2 battery packs in here. They're packaged in the center line. And each of those battery packs hold 82 kilowatt hours for a total of 164.
Is that usable?
That is total energy. So usable is a little less. We're running usable around 80% of that.
Okay, sure. And you always want some buffers, of course, in this situation because maybe our audience isn't totally aware. You have the hydrogen fuel cell that's producing, you know, essentially it can just sit flat out. And then the batteries are taking this hit of regen and then big acceleration. So you have a battery buffer. And then that is run over. So how big are the batteries in the battery electric truck?
In the battery electric truck, we're running 733 kilowatt hours total energy.
Yep.
And then
usable is like 680 or something.
Something like that.
Yeah.
So the regenerative braking capability on the battery electric truck is a little higher from a power point of view, right?
Okay.
We're also running, for the fuel cell truck, we're running a brake resistor together with the batteries. So if you're in long downhill scenarios, we have to utilize that brake resistor.
Okay. So how does that work? That means the electric motor still goes into regenerative mode or in generation mode.
Yes.
It just burns it off as heat.
Yeah, we still use the battery first,
Yeah.
but when the battery is at its limit, for example, from a power point of view, then we're utilizing a brake resistor on top of that.
Ah, okay,
But
cool.
for efficiency reasons, we always want to store and use the energy, obviously. So we only utilize the brake resistor when it's absolutely necessary.
When you're at like 80 or 90% and it can't accept that much energy.
And when the fuel cell is running at a very high power and you have to essentially do a load shift and ramp down quickly, that's where we can also utilize the brake resistor for these transient events.
That's kind of cool. And so where is that located in the truck?
The brake resistors are actually located as part of our backpack assembly.
Okay.
So if you tilt the cab, we can actually see them attached.
So we'll be able to look into that. Okay. So 70 kilograms of hydrogen.
That's correct.
How far can you go?
500 miles.
With a trailer?
With a trailer.
And that's how heavy is the trailer?
That can be fully loaded, 82,000 pounds.
Okay.
It always depends on the route. It depends on the speed.
That's what I was going to ask.
The drivers. So it's really hard to just talk about, one range.
Of course.
It really comes down to how you operate the truck. If you're, for example, if you're driving up and down hills all day, every day with a full load, you're probably going to have a little less range.
Yeah.
If we're having light loads, and especially in California with the, the speed limit to 55 miles per hour, that obviously helps us or everyone when it comes to efficiency. And so if we're running, for example, in port application, we can see a higher range than that too. 500 miles is a range that we see as a kind of a solid average.
It's like a good communication range.
Correct.
Because unlike, maybe our viewers don't necessarily know this, there's no like, I forget the exact J code, but there's no like 5-cycle test that you can run the trucks through or anything that's comparable. It's each truck manufacturer must say in some way, here's how we expect the trucks to be used, and in this scenario, here's our efficiency, and here's how much energy we have, and then here's your range. But it's up to you guys to spec all of that.
That's right.
I would like to do some independent range testing.
Oh, absolutely.
It'd be really fun.
I'm all for that. I mean, again, what we publish, we stay behind. We've done a lot of internal testing. We've done a lot of demo operation with fleets, and these are the numbers that we see confirmed. But again, it always comes back to what are you hauling? What are your routes? What is your driver behavior? That last one.
You can bank on 400 no matter what, more or less. Yeah.
And the driver behavior is an interesting one, because what we learn is, and that goes both for the battery electric and the fuel cell electric truck, when a driver first goes into the truck, it's different, and they all enjoy it, they like it, but there's a little bit of a training aspect to get to the best efficiency, right?
Sure.
And what we've seen with some of the fleets and drivers is, I mean, they see this as a challenge.
Okay.
So they actually take it as a challenge to do essentially hypermiling and say, okay, how far can I go with that much percent of hydrogen or battery or whatnot.
Yeah.
So it's actually interesting to see how much of a a game for the drivers as well this can be, or for the challenge to say, okay, how do I get the most out of my fuel or battery state of charge? So.
Love it. So to the numbers on this truck.
Yeah.
We have less power output or the same power output than the battery?
Yes, we use the same e-axle, so fundamentally the e-axle can have the same power output.
Yes.
In the battery electric truck, that power output is 480 kilowatts,
yes,
or 645 horse. For the fuel cell truck, we actually downgraded it a little bit for two reasons. So we run 400 kilowatt continuous.
400 continuous isn't bad.
Yes,
yeah,
yes.
Okay.
It's 536 horse.
Yeah.
And the reason we downgraded it is twofold. One is we did have some complaints about tire wear.
Yeah,
sure. So
with
the torque and the power on the BEV, we needed to make sure we retune that slightly. Mm-hmm. And for some of the fleets, quite frankly, just the sheer power that the trucks have is too much too. So we're working on some individualization settings
like
as well.
Like a derating setting. Okay.
Correct.
These are good problems to have.
Yeah, absolutely. To tune that into whatever the fleets want.
Yeah.
The second point is we have, as you mentioned earlier, a fuel cell power module and the batteries work together.
Yes.
The fuel cell power module is spec'd with 200 kilowatt, 270 horse.
Continuous.
Continuous. That's a
flat out.
That's a system level output. Yeah. And that's actually rated end of life. So that's accounting for the degradation we'll see over life.
Okay.
Which that's an important one.
Even at high elevation, what's your impression of that? Because you'll lose efficiency at high altitude?
If we go at very high elevation, we will have a derate due to the air, obviously density, and then with the compressor, we will see a derate. So there will be a derate at very high altitude.
So maybe 10,000 feet or something like that. Because I know you guys were just with our friends actually in Colorado doing some testing.
Yes.
And our friends were filming that. So shout out to Timon. And they said it was awesome actually. They were like, you guys were ripping.
Actually, the results were a bit better than we we hoped for as well when it comes to altitude.
Yeah. But roughly 200 kilowatts.
200 kilowatts. And so the rest comes from the battery. So now we're using the battery for dynamic load scenarios, as you already said. So obviously the fuel cell cannot power the full continuous power. So to have a better and consistent performance of the overall truck was another reason to say, okay, we'll run it at 400 kilowatt continuous.
Is there ever a scenario? I mean, I imagine there must be in theory, but in real application of our highways, is there worst case still like a Davis Dam test or something? Are you ever running the battery out to zero? Is that possible?
We're utilizing the battery heavily when we're talking about mountain roads, right? So one of the most challenging ones, because of a combination of things, is actually right by our office, so to say, when we drive up to Flagstaff. Flagstaff is interesting because of the combination of the terrain, the grades, up and down, and kind of the mix in it, and then also the temperatures we can see at during the summertime. It gets extremely hot. So the combination of that, the grades and the hot environment is a pretty challenging combination. But we also run Davis Dam, for example, and all of the known kind of extreme scenarios as part of our validation testing.
Sure.
We do winter testing as well. We went up to Smithers, Upper Peninsula in Michigan, Smithers Testing Center, to run a lot of tests there and also do mileage accumulation there. Same in Colorado, high altitude, you mentioned it. And so when we run those extreme kind of scenarios, then we for sure are utilizing most of the usable energy in the batteries.
Right.
That's where it comes back to software and controls, right?
Yeah, that's the fun stuff. It's like how much buffer do you allow? When do you start derating?
Exactly.
And so like, let's say, I mean, our viewers are really familiar with I-70 because we live in Colorado.
Yes.
We're always doing it. Our friends TFL have their hill climb challenge, basically. The world's toughest towing test. I'd love to see this do a TFL.
We should do that.
We should get you guys to do that because that would make a great video.
We've done some content with them.
Yeah, great. They're great. I love those guys, and that would be cool to watch. Let's do it. But if you're doing a test like that where it's 6 or 8 miles of just constant 10+% grade, I don't know what the exact numbers are. At what point do you start derating the motor output so that you don't bottom brick the battery?
Yeah, very good question. So That's all part of our pretty sophisticated energy management, what we call it. And it's all about managing the state of charge. And that's not only once you're in that situation, but in preparation of it.
Sure.
So typically we keep the state of charge at around 50, 60%.
So that's like normal cruising. So you allow for
Correct.
regen
So
and
we allow,
hits.
correct. So we have a little buffer up and down. And what it also does is, if you look at electric vehicles, right? And depending obviously on the chemistry, you have recommendations to not charge beyond 90% or even 80% or something. Because the degradation mechanisms that you see at that high state of charge or very low state of charge are accelerated compared to sitting, for example, at 50% SOC. So the energy management is not only to improve performance, or efficiency, but also to extend the life of the battery and the life of the fuel cell. So durability is one of our optimization targets as well.
And sorry to interrupt, but you use NMC in this.
Yes.
Why not LFP? Is it just because it's hard because you'll never top calibrate it?
So there's a lot of obviously decision factors going into that. And when we initially designed the product, we went with the NMC technology or chemistry. For the future, we're definitely looking at all of the different options we have, and LFP is a strong consideration for both products.
Yeah.
That's for sure.
So you think LFP could even work in this type of scenario where it never really completes a charge cycle because the voltage discharge curve of LFP is so minimal.
Yeah.
So your BMS has to be so well tuned to know what's in the battery.
Absolutely.
Yeah.
But we really, in this architecture, we face a challenge that we have relatively high power, but also relatively high energy demand.
Yeah.
So we need to essentially have a design that is somewhat balanced between energy and power, which is not typically what you have. Even in a hybrid, you're usually more on the power side of the battery. And if you're having, with an EV, you're more on the energy side. So here we kind of need the right combination of both. So that makes it interesting.
What about thermals? Like we were talking about all these hill climb tests, hottest day, going up to Flagstaff, your wide open hits on the uphill, full regen on the downhill.
Yeah.
Does it ever thermal limit or is it battery limited before it gets too hot?
There's lots of limiting factors that can come in, and there's definitely scenarios where you have thermal limitations. And that's actually for the fuel cell also one, because if you go on a hot day and you have to climb those steep grades, you're at lower speeds because of that.
Yep.
So now your ram air obviously is not as much, and you have to start cycling your fan, which costs a little bit of power too. And so that's about, for the fuel cell, the worst case.
Right.
Cold climates are actually not that bad.
Well, and you get more air density in the cold anyway.
Yeah, right. And we have, the fuel cell does generate a substantial amount of heat.
Yeah.
So cold climates are in general more favorable than very hot climates, which is a little different than battery electric.
Yeah, that is pretty interesting.
Right?
So my understanding is you have some trucks in service in Colorado with Roy. I think he was in our previous video. And so I guess he's running some trucks.
We're running trucks up in Colorado, yeah.
So when you park them and it's, really cold temperatures outside, do you have to purge out the fuel cell so the water doesn't basically freeze inside of it?
Very good question. So there are a lot of functions to handle the water inside of the fuel cell. So there's also functions to handle the water in the exhaust that you have going through there, right? At the end, we have a very, again, it's part of sort of the thermal and the energy management to work with the warm-up scenario as well. For example, if you have the truck sitting, could be MBD off, so completely turned off, and you have it sitting at minus 30 C or F or whatever.
Yeah.
It's pretty similar at that point anyways.
Yeah.
And you essentially have a frozen truck, right?
Yes.
And so now you have to go through the warm-up procedure to heat up the system.
Yeah. Same with a battery electric truck too. It wouldn't accept any energy or anything if it was that cold.
Yeah.
So what do you do?
Yeah, that's a lot of the development we did, and when we were out in Michigan to test exactly that. And so we have a pretty sophisticated thermal system where we combine a couple of loops as well.
Okay.
And I mentioned something like the brake resistor before. Well, that part has a dual function, let me say that. And we do utilize that to essentially being able to heat up the system quicker. And once we have the fuel cell going, we can also use that generated heat to heat up some other parts of the system.
So it starts with the resistor because that doesn't care about temperature. You get that thing starting to warm. Once the fuel cell comes up a little bit up to temperature, you can use that.
And we're still utilizing the battery, but we don't need to pull that much power out of the battery, which we're very limited at these kind of cold temperatures.
Yeah, of course.
So
I'm learning so much. I really can't think, like this is great content.
Yeah.
We could go for like 6 hours.
Oh, we could. Sorry. Usually if I get started talking, it's hard to stop me.
But you know, also like kind of sidetracked, it's like so important that Nikola has you as a representative, especially because our audience really appreciates this type of stuff. And so I'm just soaking it in as much as possible.
Sure thing.
So, okay, high level overview.
Yes.
You have 700 bar pressure. Why not 350?
Because we want to be able to store enough hydrogen to make this application work.
And we said
from the beginning, regional day cab applications, we said 500 miles.
Yes.
That needs to be a range we can achieve, you know, achieve in the real world. So we said, okay, we need at least 70 kilograms of hydrogen.
Okay.
And it was very difficult to package that at 350 bar.
Sure, that would require even another tank, perhaps.
More tanks, yes, correct. So, and that's what we see in the industry. I mean, there were certain projects that started out for heavy trucks as well for 350 bar storage pressure, but most OEMs go now towards 700 bar.
Yeah.
And in fact, we're working in industry consortium to develop even higher flow fueling hardware for 700 bar, and as well as in the standardization groups and ISO and SAE.
Yeah.
So
how long does it take to fill it from dead to full?
We can do that in 20 minutes.
Okay, that's good.
Dispenser permitting, meaning we need to have the right dispensing capability as well, and the right flow. But if we have that, the truck is capable to do a 20-minute fill.
And the battery electric truck can charge at 300 kilowatts?
350 kilowatts is what we do today.
And what's the 0 to full on that?
I mean, you hardly go 0 to full.
But just for a comparison, maybe 2 hours? Because you really slow down.
2 hours plus, 2 hours plus to do a complete fill.
That's a big difference.
Yeah, it is a big difference.
Is that the main reason why hydrogen is taking over in the Class 8 semi space?
So I would say, I really don't want to talk about takeover or something.
You support both technologies.
Right, it's not either or, it's and. And what we
Okay.
always say is zero emission, one platform, and two powertrain options, right?
Yeah.
Because there's applications for both of them. There's really advantages that battery electric technology and battery electric trucks have. There's also, for example, advantages right now when you talk about the total cost of ownership. And there's many applications where a battery electric truck works well.
Can you give me one example where someone would choose a battery electric over a hydrogen?
Well, especially if you start with smaller scale deployments and not that many trucks, where you may already have the electric infrastructure to support the charging. Let's just say you buy 2 trucks, you have enough electrical feed to install 1 or 2 chargers, and your operation is 1 shift.
Sure.
It's only 150 miles a day or 200. Inner city kind of distribution, for example, urban environment. Great application for BEV. But think about, you want to scale it up to hundreds of trucks. Now you have to have a new electrical feed. You probably need to build a
the biggest
substation,
limitation
right?
to that.
Yeah, exactly.
Yep.
So that's something to worry about. But then also you have many applications that are slipseat, multiple shifts, where you typically have half an hour between shifts.
Sure.
We can support that today. Now, we're obviously working on megawatt charging technologies in the industry, better batteries, improvements there, and it will improve, but so will hydrogen. And to me, there's always going to be different applications where one or the other product is better. Here, we have 500 miles. We can already support a 2-shift, right? Less than half an hour for fueling. And you have more payload as well. So we have the tractor weight is less, so we have more payload capability too. And that's important.
What is the increase in payload on this?
That compared to our battery electric truck is a little over 3,000 pounds improvement.
That is not insignificant.
No, it's substantial. And we obviously, weight still is something we're working on. We haven't fully solved that, full transparency. We're not perfect, right? With this truck, and there's areas we need to work on. Weight reduction is one of them, cost reduction is one of them, where we put a lot of effort in. But we'll get there.
Is the battery electric truck more money than the hydrogen truck?
Cost to build it? You mean? It depends. Obviously, we've already launched a battery electric truck last year, so we've already taken cost down measures. We've already produced some. For the hydrogen electric truck, we just started production. We're ramping up, so we need to scale up.
Come down.
Correct.
As scale goes up.
Exactly.
But
so,
in the future, you think that this could be cheaper to build, or they will reach parity?
I think it can be cheaper in the future. Yes, as we scale up and also as we do technology improvements. Right. Today, the hydrogen storage tanks, Type 4 tanks. You said we have 5, right?
Yeah.
Each holds 14 kilograms. That's usable.
Okay.
So that's already accounting for the residual pressure we leave in the tanks when you defuel.
And is that something that you guys control, the residual pressure?
Yeah.
Is that through software?
Correct. So there's advancements, just talking about, for example, the safety factor in those tanks, where in the future, as we can go down with the safety factor because we have the process better under control, we can increase the amount of hydrogen we store, but we'll also decrease the weight of the tanks and the cost of the tanks at the same time, right? So this is a good example of there's lots to come in the near future where we can improve on that.
And these are all Bosch tanks, or are they your tanks?
No, we're working with Hexagon for the vessels itself, but then we own the design of the hydrogen storage system overall.
But the stack is Bosch.
The fuel cell power module was developed together with Bosch.
Specifically made for this application.
Correct.
Yeah.
We started collaborating about 5-6 years ago.
Yeah, wow.
And that's where I actually come from. I used to work for Bosch. So.
Nice, yeah. So this is your baby from the beginning.
It is. Yeah.
That's amazing. I want to do a whole episode on what I don't even understand how a fuel stack works.
Yeah.
Is it called a fuel cell, fuel stack? What do you even refer to it as?
Well, we refer to the overall system as the fuel cell power module, which consists of 2 fuel cell systems, each with 1 fuel cell stack. So that's what we call the stack of individual fuel cells.
Yes.
And then we have all of the components around it to run the whole system.
So the proper term is power module.
That's how we call it. But
I like it.
Others call it fuel cell engine, right?
Yeah. Okay.
This fuel cell system.
Can we lift this up to see what's behind here?
We absolutely can. Yes.
So Jordan, come around this way. Let's take a look at how this works. This has got to be the coolest thing. Like, it's just great to learn about, for me, how all this works. So I'm absolutely loving it. Now, my impression of tipping it forward was to get a lot of speed on and slam on the brakes, and then the truck would flip. But I guess it's done electronically. There's some process. So he's got in there clicking buttons. So the software, by the way, is all Nikola. We showed that with the battery truck. They designed, spec their entire software stack, interface, HMI, as well as control modules for everything. I thought that was really nicely done. So there's that. Come on over, Jordan. Cool.
You probably wondered what I did inside. So since the tilt is actuated here from the outside with the remote, we don't want, obviously, anyone to just come up to the truck and being able to tilt it.
Right.
So there is an enable button inside that you have to actuate, and that's after you put your driver pin in to access the truck. To put it essentially into an enable.
So I can't just walk up to it.
You can't just walk up. We obviously don't want that to happen.
Right. Yeah.
So.
And how often would a driver need to do this?
It depends on the inspection, or if you do need to do coolant fills.
Sorry. That's all good. This is some heavy equipment you're working with here.
It's
so that's the main fan.
That's the main fan and fuel cell. So fuel cell fan and radiator, right?
Okay.
This is actually one of our last prototypes we built. So you'll see that there's some components like the coolant tanks that are still prototype. Most of it is production spec parts and designs, but there's some changes we did for the production truck still.
Okay. So. Very cool. This is wild.
So
it lifts the whole thing up hydraulically.
Yes. It lifts it up and then it lifts it forward.
Oh, cool.
So it will all come up forward. So just clear the front area.
Don't stand in front of it then. This is cool.
That's the part my kids enjoy.
Yeah, this is great. It's like it lost something and it's looking for it. So eventually gravity takes over.
It's a pivot point, yeah.
Yeah. Dave, you can see the hydrogen storage back over here. So 3 tanks right there in view from Hexagon. Okay, that is so cool. You don't want to be sleeping in there and then get woken up. So, yes, this is awesome.
It's the heart of the truck, you could say, the fuel cell power module.
So it fits into where a normal like V8 diesel would sit.
Where, yeah, a diesel engine would fit in the engine bay. You can also see very nicely here the 3 hydrogen tanks as part of, we call the backpack assembly. And then we have 1 on each side, so the total of 5 that then goes into a common manifold and ultimately supplies the fuel cell as
So
well
this
as...
is that, and why is it user accessible here? Just in case you need to tighten anything, or what's the idea for having this right here?
It was a package consideration based on where all of the hydrogen tanks are and the lines run, right? Because we run right here from the tanks, and then the side. We also have the fill port here.
Can we open that?
Yeah, I would need to
it's the cab. Okay, so lower.
It's a similar aspect of we don't want anyone to just being able to access it, but that fill port essentially goes right in here as well.
So that goes into this bus bar, if you will. Yeah. I don't know. That's the electrical term of it, I guess.
The electrical term would be bus bar.
Yeah, okay.
And then you will see the hydrogen feed actually goes on the other side into the fuel cell power module, along with the air intake, and then ultimately the exhaust that goes on the bottom here along into the rear.
So where's the exhaust? Sorry?
You might be able to see it if you look right through here.
Okay.
Those 2.
Yep. Is it on the camera there?
Hoses.
Yep. Okay.
That's the exhaust lines.
Great.
So they route towards the rear and come out ultimately around here.
And do you have a storage for the water and then you purge, or does it just flow out?
It flows out.
Okay.
We, as I mentioned before, there's a lot of controls in place regarding the water management overall.
Yeah.
But we don't have any like compartment or something where we'd store the water.
Okay. So you have your hydrogen turned into electricity here.
Correct.
And then the high voltage lines go to because it comes out as AC or DC?
It comes out as DC.
Okay.
We can actually, if you want to go around, I can show you the...
and then do you have to step up or down the voltage with the DC to DC booster?
That's exactly what we're doing. So we have the battery pack and the fuel cell power module. So obviously we need to get the voltage levels together.
Yes.
So the master voltage is essentially the battery, is defined by the battery.
Yes.
And then we have the stacks itself are these boxes here.
Okay.
And this one is the power distribution unit per stack that's right attached onto the stack, and that's where the high voltage DC lines run out and then go into a DC-DC converter.
Okay.
And that's where we boost the voltage up to the battery level. So we're running a little lower on the stack typically.
Was there a reason for that?
It comes just from the architecture. We have each of the individual fuel cells has a potential of about 0.65, 0.7 volts.
Okay.
We have 455 cells in a stack.
Okay.
So it means we're running the fuel cell itself around 400 volts.
Okay.
And then the battery typically runs around 680, 690 volts.
And that's at 50, 60% nominal or so.
Yeah.
Okay. Yeah. What is it when the battery's at 100%? Almost 7 something?
Yeah, a little over 700.
Okay. Very cool. This is fascinating. So each power module or fuel stack, is that how would you describe each one of these things?
So as mentioned, we call the whole assembly. It's one assembly, the fuel cell power module.
Yeah.
And then each of these systems, so you can see very distinctively, it's 2 systems.
Yeah.
It's what we call a fuel cell system, and each of those can run independently.
So if one dies or has an issue,
correct, one can continue to run.
Ah, great.
Yeah.
Okay, that was
and
my
then
main
yeah, and then the stack itself is kind of this larger box behind.
Yeah.
That's the fuel cell stack, and then you can see all of the other components, coolant lines, electrical lines, and so on.
And so all of the braking system, the air suspension system, the trailer brakes, that's all the same battery electric or hydrogen.
Yeah.
The same electric compressor,
Yeah.
if you will, powers the air systems on the truck.
That's correct. Yeah, that's correct. Most of these parts are shared. The same goes for the steering system, for example.
Okay. You have an electric steering rack, I guess, all of these things.
Yeah.
What about this door here? What is this one for?
That's the same as well as in our battery electric truck. It's a master battery disconnect switch where you essentially can switch off the whole low voltage supply to the truck to, for example, if you do longer storage or something.
Right.
And then we have the attachment or connection points for a low voltage charger here as well.
Ah, okay.
It's
cool.
That switch is pretty common for trucks too.
Amazing.
Yeah.
Well, that was like the most information-filled tour I could have imagined. So we should close it back up, and then maybe we can go for a ride.
Absolutely. That's
So
the
cool.
most fun part.
Yeah, that was really, well, I actually think this was the most fun part because just learning so much about all of this, this was really great.
Yeah.
So does it just fall down?
No, it's controlled. I mean,
Okay.
there's the pivot point where gravity takes over.
Yeah.
So you'll see in a second, you will see the little swing down.
Yeah, yeah.
But it is, so now you have.
And this is just normal for Euro trucks anyway. We're just excited because it's in America.
Yeah. But it's kind of cool, right?
I mean,
That's why I said
it's
my
really
kids
cool.
love it. It's like it's like a transformer kind of deal, right?
Yeah,
So
I love
how
Euro
can you
trucks.
not love that?
Yeah. And you were mentioning while this is going down that you're running a different tire on the drive axle.
Yeah.
Single motor at the moment.
It's a dual motor,
okay.
single E-axle.
Okay,
Yeah.
so are they mechanically connected left and right?
Yes.
Or? Okay.
Yes. They go into a differential.
Okay, so
So
there's
it's not
no
an
possibility
individual-
for torque vectoring.
No,
or
it's
anything.
not an individual, wheel motor setup.
Okay.
So
And then it just locks into place. How cool is that?
yeah,
That is neat.
it is very, very neat.
And you're running obviously a drive tire on the. Everything's Michelin tires on this particular one.
Yes, that's
but
correct.
On your tag axle on the rear is more like a mileage tire, not like meant
That's
to be
correct. That's
a drive tire.
not as much profile, so to say.
Yeah.
As the drive type tire. So
Okay. Well, now you guys can see how it goes back together. We'll get in and go for a ride. This is epic.
And then what we do is we kind of change the visual here in EV mode, and then it also gives you the range actually on battery only.
So we can do 21 miles estimated at 86%.
That's
before we have to turn on the hydrogen.
that's on battery.
Yeah,
but now I'm
that's
going to
also
switch
good
it.
for storage, right? Because you would want to drain it down to 30 or 40% before you do a cutoff.
Yeah, you could do that. Exactly,
Okay,
you could
yeah.
do that. Now I'm going to go into essentially normal mode, so to say, and you'll see that the range, the visual switches, and you can see the range went to 204 miles in this case.
Right, and we're pretty
with,
low charged.
Yeah, with 36% here.
Yep.
Is a little more detail. And some of this is very similar to the BEV, so I know you've been going through that before. In
Yeah, it's all your own software and it's gorgeous. It like is
Thank
snappy.
you.
It's like,
Thank you.
and we met the dude who does a lot of the software.
Yeah,
It was cool.
I think Lamech was.
Yeah, Lamech. Yeah, that sounds about right. Yeah, it was amazing. I mean, I just thought it was so well done.
yeah.
And no one knows.
Yeah.
That's the thing. It's like you built your own software stack to run this truck.
We actually designed all of the hardware for the controllers too.
Oh, wow. No way.
And then we're working with, contract manufacturers essentially. Yeah, so the visuals are updated. Obviously, we're in a fuel cell truck. You have some new buttons about fueling and so on. And then you also have the hydrogen storage capacity instead of the battery SOC. So let's go for a ride. So you hear the fuel cell coming on?
Yeah.
So that sound is the fuel cell coming on?
Oh, it's got one pedal driving almost.
Yeah. Actually, let me put the regen.
So that's full regen, same as the battery truck. This is so cool. We're in a Euro truck. Hell yeah, brother. Just roast the tires. Oh, it's freaking epic. That's how I drive this thing.
Thank you.
This guy in the Q8 e-tron is like, let me get out of everyone's way right now. He's got it in off-road mode. I don't know why. Jordan, show how high the suspension is on that thing. What are they doing? This is Los Angeles. Drop it down. Man. Hell yeah. Oh my gosh, just roast the tires. So is it...
Oh, that was like 20% pedal.
20%. This is cool. So I'm surprised how quiet the fuel cell is. Yeah. I mean, normally, like with the Ram Air, it takes a lot of noise. So when you're under load, does it make more noise?
When the fan comes on, right? I mentioned we have, so you can see the regen coming in.
Yeah,
if you're bobtail, that's almost too much already.
Yeah. Does it have regen drag control?
Drag
so that if you start to lock up under regen, it'll release some.
Oh yeah.
Okay.
It will. Yes. Like traction.
Traction control and reverse.
Or lock control. Yeah. Lock.
Yeah,
absolutely. So that system is the brake system controls is fully tied in with the propulsion control, so to say, and it goes for regen and as well as propulsion. So
this is the freaking jam. Colton, what's your impression of this?
This is insane. Well, I've never been in a semi before anyway.
And now we're in a Euro semi, a cab over.
So cool.
As a first semi experience, this is great.
Well, I think now you can understand why one of the favorite parts of my job is to just drive those trucks.
So will it regen to 0 when you lift off all the way?
Not quite.
Okay.
That's also something we're still optimizing.
Do truckers even want that?
Potentially. It depends. I mean, the more they get used to regen in general, the more they want to essentially use it to the most extent possible. So
I'm just amazed that you don't hear the fuel cell at all.
Yeah, it really becomes, what becomes louder is if the fan goes on.
So it has blind spot indication.
It does.
That's cool.
Lane departure warning and adaptive cruise control.
So should we launch it? Settings, traction control off. Hell yeah. Can you 2-foot launch it? Does that help? To hold it on the brakes under the power?
Don't need that.
Oh.
I mean, you have instant torque, right?
Yeah.
You only need that if...
Hell yeah! Dude, that's fast! Oh my god! That is crazy! Thank you for getting in trouble for that. I appreciate that. That was freaking great. Oh, so much fun. Thanks for the ride. That was epic. Well, this thing rips. That was awesome. We left some nice marks down there, allegedly. We can clean them up.
I don't think it was us.
We can clean them. That's right. There's other trucks here that are around. Thank you so much for the tour,
Absolutely.
the information.
Yeah.
It's something where we should probably come to Arizona to the proving grounds.
Absolutely.
I want to do a tug of war of my Rivian and one of these things.
Oh, we should do that.
Yeah, it could be pretty fun.
No, you're welcome anytime.
Thank you so much. It's one of those things where, of course, around Nikola, there's a lot of skepticism. Hydrogen brings a lot of questions. I think it was great to learn more about what you're doing, experience the truck firsthand. I want to do one of the Flagstaff routes with you guys, put 80,000 pounds on this thing or whatever you can, and then go up to Flagstaff and down. Should be pretty epic. So let me know what you guys want to see. Class 8s, or really any heavy duty electrified vehicles are necessary, and even more necessary than passenger vehicles, because these are running constantly in fleet applications, and to reduce carbon, these solutions are needed. So thank you so much for the tour. That was amazing.
It was great.
And love that we ended it with a burnout.